Hello, nephrons. Today we'll be talking about the renin angiotensin system. We'll start with a basic structure of a human nephron. This is the glom, this is the proximal tubule, and then you have the thin descending limb, then you have the thick ascending limb, and then here comes the distal tubule. The tubule makes contact with its own glom. So this structure is made in such a way that the distal tubule of each nephron makes contacts with its own glom. This way, the system develops a self-regulatory mechanism, if I may say so. What it means that there is an apparatus that is formed here. This is called the juxtaglomerular apparatus, which is nothing but specialized cells of the distal tubular cells. Some of the mesangium here, as well as the smooth muscle cells of the afferent arteriole. And the afferent arteriole. The glomes are formed here, and then you have the afferent arteriole. Okay, so this is what the juxtaglomerular apparatus looks like. So if we sort of magnify this view, you will note that there are small secretory granular cells in the afferent arteriole part. These are nothing but vacuoles containing renin. So when the perfusion to this glom is reduced, what happens is that filtration within the glom gets reduced. Less stuff reaches the distal tubule, less stimulation of the juxtaglomerular apparatus. Chloride is believed to, in these days, believed to be the main factor here, but that's a topic for another discussion. Anyway, let's assume that there is less stimulation in juxtaglomerular apparatus. This leads it to stimulate and release of the renin from these cells into the system. So now you know that anything that reduces perfusion to this glom makes this glom makes the nephron activate its own juxtaglomerular apparatus to release more renin. So the purpose of the renin will be in effect eventually to increase the perfusion to its own glom. Now let's look at how it actually achieves this. So from the kidney, renin is released. And then let's look at the liver, which releases the protein called angiotensinogen. Now, angiotensinogen is a protein that's been released by the liver into our systemic circulation. Just like that, renin is being released into our systemic circulation under influence of low blood pressure or low perfusion to the kidney specifically. This makes the kidney release renin. What happens is that angiotensinogen is cleaved by renin to form a decapeptide called angiotensin 1. Now angiotensin 1 gets converted to angio 2, an octapeptide by the enzyme angiotensin converting enzyme ACE. Now ACE is released by most of the endothelial cells, and mostly because of the thicker concentration of such cells in the lungs and the kidney, these assume a major role. Now, what angiotensin 2 is the main player of the game. Angiotensin 2 is what all the effects of the is delivered by angiotensin 2. So let's look at a scenario where our blood pressure is low. What does our body do to compensate for such a situation? What it does is that it causes the heart to pump faster and stronger. Second thing the body can do is that body can ask its blood vessel to constrict. So when the blood vessel constrict, blood pressure goes up. And thirdly, what the body can do is that increase the volume of the circulating blood. To increase the volume of the circulating blood, the body can conserve or preserve more sodium, as well as it can reabsorb more water, thus increasing the volume of blood. Now, angiotensin 2, as I mentioned, the main player of the game, in fact ends up doing these three processes. What angiotensin 2 does is that through sympathetic activation, as well as through some believed direct activation of the heart, it can end up increasing cardiac output. Second thing that Ang2 can do is that it acts as a direct vasoconstrictor as well, or through the sympathetic itself it can cause vasoconstriction. Third thing Ang2 does is that it goes and acts on the adrenal glands. It acts on the adrenal glands, and the adrenal glands release something called aldosterone. And aldosterone is the one that goes to the kidneys, and specifically the distal tubules and the iliac channels are put in to cause more sodium reabsorption, which we will talk about more in the coming lectures. And then angiotensin 2 can go and stimulate the pituitary gland to release more ADH, or vasopressin, or antidiuretic hormone. What it does that it again goes to the kidney, specifically to the distal tubules, and cause more water reabsorption. And thus, the three processes that we talked about to increase blood pressure is achieved by angiotensin 2. Increase cardiac output, vasoconstriction, increase sodium reabsorption, and increase water reabsorption. And in net effect is increased blood pressure. Well, that's all about the very basics of renin-angiotensin system. In the coming few lectures, we'll talk more about, let's say, aldosterone escape, escape from aldosterone, which are both different, and then maybe a few words about the ACE2 and angiotensin 1 to 9. So there are interesting stuff in this field that we need to know, but let's start with the bare basics, and let's build up our fundamentals, and before we jump into more and more interesting stuff. That's all for now. Thank you very much. If you guys like this, please subscribe, like, and follow. I will be updating more and more content in the coming few weeks to months. Thank you very much.